Hi everybody, my name is Timothy Arment. I'm a developer and lecturer at the University of Tennessee in Knoxville. This presentation was prepared by Professor Carrie Staples and myself, and we're going to talk about the potential for using VR as a tool for learning skills that can be mapped to real life, particularly as it relates to practical skill building for students on the autism spectrum. So for the past 2 years or so, I've been working on a variety of projects in the UTK app farm, along with Professor Carrie Staples, that involves interdisciplinary collaboration between students and faculty to produce content that uses design to ideally solve real-world problems. The app farm has evolved around the question of, can academic content be learned through the design process? And to that end, we think of the student as the author of understanding rather than as a mere receiver of information. In other words, the distinction between mentoring colleagues as opposed to teaching students is at the heart of the development process in the app farm. By working with cutting-edge technology in an attempt to find solutions to real-world problems, by necessity, our research community embraces bold experimental exploration as we iterate possible solutions to the problem. In this environment, students have the opportunity to explore content, gain a technical understanding of design and production, and to develop a collaborative practice. We hope to stimulate individual creativity and inventiveness in our research assistants, urging them to make discoveries of their own and share this new knowledge while they pursue the various facets of the problem, including the limitations of the technology, possibilities of the human connection, and the relationship between the user and the experience. Learning to shake someone's hand is normally an easy task, but gaining these foundational life skills is not easy for students who are on the autism spectrum or who have other intellectual disabilities. In language learning, one of the best methods of content acquisition is through immersion. True immersion requires situating the language within a cultural context. Gaming provides a series of familiar mechanics and structures into which this cultural context can be situated. One of our current projects in the app farm, Bon Chance, is designed to be an immersive language learning game that manifests in the form of a mobile app. Students were then asked to retool the concept of the language cafe, or a space where students are immersed in the language, to address aspects of reluctant learners who might be shy or adverse to failure. We've developed a game environment using questions and puzzles to encourage students to actively explore course material. So this led us to ask the question, can this perspective be applied to other kinds of learning, with other kind of learners from a wide-ranging neurodiverse background? Could we leverage the immersive aspect of the technology, video games, and virtual reality to create an immersive space onto which we can map the learning of these foundational and even specialized skills? In gameplay, consequences of failure are minimal. Repetition is encouraged, even fun. Gameplay also engenders collaboration. It's reasonable to assume that once the game is available, the students will collaborate and help each other beat the game, while practicing the relevant skill set in the process. Working with faculty in the College of Education, the App Farm team wanted to explore how content learned in a virtual experience could transfer to a real-life experience. What kind of content is conducive to that transfer, and what goes into producing that content? Some of the factors under consideration as we evaluated different contexts for the experience are, did the task require specialized tools? Did the task place the operator in physical danger? Might the task enable self-sufficiency? And is it fun? The context becomes the game world. After exploring various possible world options like a garage, a hospital, a kitchen, the team chose how to make a pizza, a task which has a well-defined series of steps and that functions both as a foundational skill and potentially as a professional skill. The project was devised specifically to create a safe, fun learning environment for students with autism or other developmental disorders. Early iterations of the research went through the process of constructing the objects to build the pizza in order to figure out how to leverage technology without burdening the player. This translates to, how can we minimize the interference of the technology in successfully navigating the experience? To that end, we began development of the VR space in the Unity game engine using the Leap Motion module. Once attached to the headset, the Leap Motion identifies and tracks the player's real-world hands, making it possible to manipulate virtual objects in the virtual space without complicated controllers. This leads to a wide range of interesting questions about how to build a virtual space that can be physically interacted with, even though there's no corresponding physical objects in the real world. What happens in the virtual space when you lay your hands on a virtual table if nothing is there to stop your hand in real life? Or if you're controlling the game entirely with your real-world hands, you don't have any buttons. How do you access a menu screen or interact with a UI? How do you register an event that you would normally map to a button press so that the game engine sees it and knows that it was done? These are interesting usability questions, and there are a lot of possible solutions, so our research is ongoing. This project began right around the release of the second generation Oculus VR headsets, which support hand tracking natively. As a result, we've transitioned the project to use the Oculus Rift S or Oculus Quest with no need for a separate Leap Motion module. But this also provides us with the option to switch back and forth between hand tracking mode and controller-based mode, so we can compare and contrast the output in terms of player experience of either modality while we're working on answering these, non-obvious, multifaceted questions. Ultimately, hand tracking is a long-term solution, using technology that is very cutting edge. So there's a lot of development still happening in that space. But ultimately the goal is to get the controller out of the way and get the technology kind of out of the way so that the user can intuitively interact with the space. To that end, we've also been developing the environment so that it runs on untethered mobile hardware, meaning the headset doesn't need to be connected to a computer to run. It can just run on the headset by itself, just making it easier to kind of transplant around and to set up and get running. The project so far has players making a pizza in a home kitchen with common kitchen tools and appliances, but we're also very interested in how the skills can translate from that initial environment into something more professional or industrial, so how these skills can scale up to broader professional applications. To facilitate an understanding how the technology is working, the pizza making process is divided into a 20-step task analysis. This serves two functions. From the education research side of things, this makes it possible to assess the student player's progress, where they're having trouble, and how smoothly skills transfer from real life to the virtual space and vice versa. Additionally, this 20-step structure provides the progression metric and action to determine how the game can be divided into levels or scenes. To determine the boundaries of each step, we thought about where the player is positioned in the space, when it was necessary to move around, what tools were being used in the virtual space, and how we can frame the task so it's possible to identify that the correct action was performed from inside the game engine. So to start with, players are asked to wash their hands, always an important part of meal prep. After the player washes their hands for 20 seconds, they can set down the soap to complete the task. In an effort to connect the virtual space to the real world, we had a real-life video of pizza making created by a colleague working on this project as a part of his PhD thesis work. At any point in the game, the user can look to the screen on the shelf to see the video that's basically going over the expected steps to complete in order to complete the stage. Additionally, one of our students recorded vocal instructions that play in the background at the start of each stage. And this all kind of goes into this idea of creating a welcoming environment for the user. We want the person that's in the headset to not feel intimidated by the technology or the space. We even had an interior architecture student working with us in the app farm while we were developing the space to help us build something that was really kind of conducive to learning the tasks in a non-stressful, peaceful environment. Because to some degree, we want the students that are actually in the headset performing the tasks, we want them to sort of tell us how they want to learn or how they best learn. And that's kind of the point of all of this, and it's definitely kind of where the interplay comes in between the design team in the app farm and the primary content authors who are working directly with the students. At this point, students can begin to flour the work surface, pick up and place the dough, and begin rolling it out over the floured surface using the rolling pin. Once the dough is flattened, we progress to the next stage where we can apply sauce and toppings and finally place the pizza in the oven. We currently have about half of the tasks in our task analysis translated into the game world, and we were planning on more in-depth testing of these mechanics over the course of 2020, just as the pandemic put teachers and students alike in kind of survival mode in terms of taking their classes online smoothly. But this is where progress on this project currently stands. VR has an unprecedented potential for immersion, so we're interested in how we can use that to create an environment built around learning the core skill, which can then map to the real world and the real space. And by learning these skills in VR, you're in a safe place. In real life, failure could be expensive or even dangerous when dealing with kitchen appliances, for example. In the same way that VR can be used to train surgeons in safe virtual simulations, or the way that simulations are used to train pilots in safe low-stakes spaces, with this project in particular, we're interested in exploring how these same highly technical and specialized tools can be used to teach, learn, and reinforce foundational skills for a neurodiverse community. Thank you so much for watching, and if you have any questions or comments dealing with our VR work or the app farm in general, feel free to reach out to me or Professor Staples.